and YouTube blog covering the German startup scene with news, interviews, and live events.
Hello and welcome everybody to another episode of Startuprad.io. Today we are attending Curious 2024 and we just got an amazing interview guest, Professor Avi Loeb from Harvard University. Very welcome to Startuprad.io. Can you briefly introduce yourself?
It's a great pleasure to join you. My name is Avi Loeb. Fundamentally, I'm a curious farm boy. I was born on a farm and was connected to nature since a young age, and became a scientist so that I can answer questions about nature without needing to listen to the adults in the room telling me the answers, telling me their opinions. I was chair of the astronomy department at Harvard for 9 years, the longest serving chair. I also served as the founding director of Harvard's Black Hole Initiative, and I'm the current director of Harvard's Institute for Theory and Computation. I work primarily on theoretical astrophysics, studies of black holes, the first stars in the universe, and most recently, the search for extraterrestrial intelligence, because we don't find it here on Earth.
That's already pretty exciting. Since you are a scientist, what do you believe are the most exciting future avenues for scientific research?
Well, there are some fundamental questions that we don't have the answer to. I call these the known unknowns. In other words, these are things we know that we don't know. For example, what most of the matter in the universe is, 85% of the matter is of a substance that we never identified, never detected. And so we are still in the dark, and it's called dark matter. There is also the substance that makes up the vacuum. You might think the vacuum is empty, but in fact, not so. It turns out that there is some energy per unit volume, and that is called dark energy. And we know that it exists because the universe is not just expanding, but its expansion is accelerating over time. And that means that there is a repulsive gravity pushing the universe apart. And the question is, what is the origin of this dark energy? Why is it there? Why isn't the vacuum completely empty, for example? And we also know that if we go back in time, there was a beginning to the universe, the Big Bang. And we don't know what happened before the Big Bang. These are fundamental questions that we don't have answers to. We also don't know what happens inside the black hole. Where does the matter that falls into a black hole, where does it collect? Does it collect at the center, or does it go somewhere else, like water going down the sewer of our homes? So these are just some fundamental questions about the universe, but there are many more that I can mention. And I think the most fundamental in my mind is, where did we come from? What was there before the Big Bang? And in particular, I'm curious to know whether the Big Bang was created artificially by a scientist. Because if we ever understand how to unify quantum mechanics and gravity, we might have quantum gravity engineers that would have the recipe for creating a baby universe in the laboratory.
That are all very interesting avenues for future research. What emerging technologies do you think will have the greatest impact on scientific advancement in the next few years, talking about the instruments you can use for research?
Well, in terms of instruments, of course, the most important is computers, if you call it instruments. I mean, that improves our cognitive abilities, and artificial intelligence, machine learning are entering into the scientific study of large data sets, and also going through data that the human brain is unable to process. And that already starts entering physics and biology. But I see a great future ahead for artificial intelligence, machine learning, and there is an interesting question of whether those computer programs will be able to identify trends in data and figure out new laws of nature that we have never figured out before. So will they behave like scientists? And if they do, will I be out of a job? For the near future, I don't think so. I still think that at least many people complain that AI systems are hallucinating. I wouldn't hold that against them because I have a lot of summer interns that are hallucinating. But they are not at the level where they can innovate the way human scientists do, but perhaps in the future they will. And I'm open-minded about that. I think that will be the biggest breakthrough when science will be done with the aid of AI. And then the question is who to give the Nobel Prize. For example, there is already a precedent of the DeepMind company being able to solve the protein folding challenge that was really very difficult to solve for human scientists, but this AI code that they developed went through so many configurations that it was able to figure out how proteins fold when they have very big molecules. And so that's just one example where a major challenge in science was resolved by AI already.
And we're talking about research instruments, and of course everybody here is interested in startups who are listening to this. Where would you see the role in startups and how they can contribute? You've already hinted at AI. Do you see a big potential there?
Yeah, the most important thing about the innovation is that one should take risks, because very often the most important breakthroughs are not recognized ahead of time. Otherwise, they would be accomplished quickly. And so you need to explore territories that are unknown, and very often you fail, but you do that because there is a chance that you will be successful. And if you are successful, it would be a major advance. And so having startups is one way of exploring the land of the unknown, where people with innovative ideas try to materialize them and make them real, and very often they fail. But it's part of the process of arriving at important breakthroughs. And that's why startups are so important. The same is true about science. I do think that funding should be given, a small fraction of funding should be given to risky propositions that are not proven and nevertheless could change the landscape of scientific discovery. So startups play this role in the commercial sector where they explore opportunities, and I'm very much in the view of letting many flowers bloom, because you never know which would be the most beautiful flower ever seen.
Mm-hmm. You kind of hit already the next two questions that I had on my list. We're talking about startups and working together in scientific research. What are the main challenges that startups face when trying to contribute to scientific research?
Surprisingly, there is a lot of conservatism in science, even though it's supposed to be open-minded endeavor with blue sky research, in the sense that it's not supposed to be applied. But what happens is that there is another factor that enters the calculation, and that's the human ego, which is very prominent in academia. And on the one hand, you have scientists who are driven by their ego to get honors, awards, recognition, and are building echo chambers around them of students and postdocs. But at the same time, they are pushing back against new ideas because they got their stature, their position, their status, their recognition based on past knowledge. And so when they see new knowledge emerging, for example, when they see anomalies, deviations, outliers from what is known, they often dismiss it or shove it under the rug or say the uncertainties are too big. They basically raise enough dust in the air to claim that they don't see anything new. And they do it because they protect their territory of past knowledge. And unfortunately, that has the negative effect of suppressing innovation, because when young people see that, they worry about their careers, their job opportunities, and as a result, they don't take risks. They don't pay attention to anomalies. They don't explore ideas that deviate from what the senior established people already announced as valid areas of research. And it gets to a point where the theoretical physics community, for example, has been working for 50 years on how to unify quantum mechanics and gravity in the form of string theory, which is a theory that is mathematically very sophisticated, but has not been demonstrated to be true by any experiment. And doing that for 50 years means that the entire community is basically driven by societal forces, by some leaders that say this is interesting for us to explore without any experimental verification. We know from the history of science that you always need evidence to guide you, and you may be going in the wrong direction. Nobody would have forecasted quantum mechanics to be real unless experiments would lead us in that direction. We still don't understand quantum mechanics. So my point is that we really need to be humble in physics and let experiments guide us. And we can have a lot of ideas, but at the same time, we should allow them to be ruled out by experiments and then move on. And if experiments are not available, we should let other ideas appear. And that's not the case in theoretical physics at the moment. There is only one mainstream, even though it didn't get support from data. And so I see that as driven by intellectual gymnastics, by people trying to show off, just show that they are smart, by societal forces, not the raw curiosity about nature that is supposed to lead science. And it's not just in theoretical physics, it's in many other areas where progress was suppressed. I mean, even when Alfred Wegener realized in 1910 that the continents perhaps were all together based on the fact that they match like a jigsaw puzzle, his theory was ridiculed by experts for decades, and he died in the 30s thinking that it will never be accepted. But then in the 1950s, evidence about rocks and about vegetation confirmed it. That's a classic example where the progress was delayed by 40 years. And the same is true in many other frontiers where the correct ideas were simply ridiculed by experts that wanted to maintain their intellectual turf.
Mm-hmm. Talking about investments in research here, how important is investment in technology and science for the future of research?
Technology goes hand in hand with science, because fundamental science allows us to understand nature. And then once we understand nature, we can use it for our purposes. And the know-how of how to use nature for what we want to accomplish comes from fundamental science. And therefore, technology always makes use of fundamental science. And that's why science and technology should be funded. Now, technology is using what we know about science for the benefit of humanity. That's extremely important because once, for example, we develop the computer after understanding how to make transistors, then and that came from understanding quantum mechanics, so everything is entangled. But the new technologies that were developed allow science to progress much more, because those technologies can be used in sensors that are taking data, and they allow us to do computations, meaning processing of the data. So I think it's extremely important to support both fundamental science and technology, because they progress hand in hand. The strange thing is that so much money was made in the commercial sector that you might find that innovation actually happens more routinely in companies these days than in academia, or maybe they sort of go at similar levels in the case of quantum computers or in the case of AI, whereas it was supposed to be the responsibility of academia to really promote innovation much more than people who are aiming to make money.
Talking about the impact on society, how do you envision new scientific advancements impacting everyday life and society as a whole?
I think science and technology is what makes us look like an intelligent civilization, because if you read the news every day, you realize, we are doing a lot of foolish things. We invest $2.4 trillion every year worldwide in military budgets, meaning in conflicts, in trying to kill each other. That makes very little sense. We engage routinely in zero-sum games, conflicts over territories. Whether, these are just territories on the rock that was left over from the formation of the sun. It's a tiny real estate that we are focusing on. There is so much more real estate in interstellar space if we were to look up. The intelligent thing to do is actually for us to work together, to collaborate, not to engage in conflicts, because science is an infinite sum game. It's not a zero-sum game. If we gain knowledge, everyone benefits from it. So what I argue for is science and technology are much better than politics, because politics is very often a zero-sum game, whereas science and technology are infinite-sum games.
Coming close to the end, advice for aspiring entrepreneurs. What advice would you give to aspiring entrepreneurs looking to enter the tech and science startup scene?
My advice is follow your passion and do not listen to the adults in the room, because the adults in the room, first, may not have good ideas about the future, and secondly, they may not understand how innovative your ideas are. And so take the future in your hands and shape it to be better than the past. And that is the approach of a kid that is independent. And, that's the approach that I like. Being 62 years old, I'm still the kid that I was early on in my life. I realized that it's much better to do the right thing than to listen to people in the room telling you what is right to do. And I very much encourage young people to stay young in spirit and follow their passion and shape the world to be better, because there is a lot of room for improvement.
Looking ahead, in your opinion, what will be the most significant scientific breakthrough in the next decade, and how can startups position themselves to be part of it?
In my mind, the most important development in the future would be artificial intelligence taking over our life, and perhaps augmenting human intelligence. If we have a way of connecting the human brain to a computer chip. I call it putting a chip on our shoulder. It's already being done, but in the future it might be even more common. And so the question is, what will it do? And artificial intelligence at some point will have enough parameters to have more capacity than the human brain. We have 100 billion neurons in our brain, and about 10,000 times more synapses that connect the neurons. Artificial intelligence systems as of now have somewhat less than that, but they grow in the number of neurons in the artificial neural networks. They grow exponentially with a characteristic doubling time of less than a couple of years. And so within the next 10, 20 years, there is a good chance that the AI systems will have more parameters than the human brain, than the number of synapses in the human brain. So at that point, phenomena that we attribute to humans, such as consciousness or free will, might be visible when we interact with those AI systems. The other thing is that if you go to graveyards, what you see, the tradition is putting a tombstone above the grave of a person. And if you think about it, that's a very primitive approach, basically a stone on which you engrave in a few words what the person was about. And so the entire lifetime of a person is summarized in a few words. And there are two problems with that. One is that this message is static. The amount of information in it is not changing, and also that it's very little information. Now, granted, there were 117 billion people on Earth in the last 10 million years, and information was not a priority. I mean, we know that because some traditions burn the bodies of dead people, and that is basically an act of destroying the genetic information about the person. So, for example, the New Horizons spacecraft that went to visit Pluto included a small box with the ashes of Clyde Tombaugh, the person who discovered Pluto. And if extraterrestrials were to find this box, they would really wonder about the barbaric act of our civilization in destroying any information about the discoverer that it wants to commemorate. There would be much more information in a hair taken from Tombaugh's body, because it will have the DNA information there, than in the box of ashes. So that was not an intelligent thing to do, to put a box full of no information about the person you want to commemorate. But if you think about it, in the future, tombstones might be replaced by AI avatars, meaning there will be an AI system training on all the digital information that we leave behind, voice, text, videos. And once a person dies, this AI system could represent the person and imitate the person in interaction with living people. So in my mind, an AI avatar of this type would be much better than a tombstone to have over my grave. And in fact, there is a CEO of a startup that contacted me recently and asked if I'm allowing his company, new company, to make a replica of me. And of course, there are risks in allowing that, but I agreed because I see it as an AI avatar that if I'm asked in the future to participate in podcasts like this one, I could send my avatar to answer all the questions. If it's good enough, it will do a good job. And that would save me time. And especially if I die, this avatar would give a much better representation of my body of work than a tombstone.
It was such a pleasure having you here. And the next time you send your avatar, I send my avatar, and then make a recording together, okay? Thank you very much, Professor Loeb.
Thanks for having me.
That's all, folks. Find more news, streams, events, and interviews at www.startuprad.io. Remember, sharing is caring.